The last part to this is the nucleophilic addition elimination reactions of the amines, which you've literally just done. You did it last week in the derivatives of the carboxylic acids. So it is no different. And if you remember the reaction of ammonia with the acyl chloride, and then the ammonia with the acid anhydride. So we're just really looking at those. So if I kind of talk through them again. So ammonia makes the amide, and there's the mechanism there, which I'll go through in a second. If we were using primary amines, we would get the N-amide, okay? So, and again, the mechanism is in here. So because this whole section is about the amines, I'll just go through that mechanism again, just to recap what we've already done. So here's my acid chloride, acyl chloride, and I have the lone pair electrons form a dative covalent bond with the D plus carbon. The carbon-oxygen pi bond breaks, that's the weakest, and because the oxygen is the most electronegative, the pair of electrons go to that oxygen there. Now that gives me an intermediate, so R, C, Cl, O minus, lone pair go on there, display this out, NH, H, and I'll do an R group on here. Okay, that's positively charged. And then the carbonyl group reforms. These are the three curly arrows. Chlorine leaves. It goes like that, which then gives me my final product, R, C, O, N, H, R, and that is my N amide, okay? And while I've got this mechanism here, now this is with the acid chlorides, it could be with an acid anhydride, and I'll just remind you of the structures of the acid anhydrides. So that's the acid anhydride, and in terms of what leaves, if you remember the chlorine leaves here, well, this is the equivalent of that chlorine in that molecule there, which means that will leave instead of the chlorine. Again, all just a recap from the derivatives. So there's the mechanism that we get, and what we end up with is the N-amide, the N-amide here and the N-amide there. And that's really it. We're looking at it from the perspective of the amine rather than as the carboxylic acid derivative. So the primary amine with an acyl chloride will give you the N-alkyl amide. Similarly, with the acid anhydrides, you get exactly the same thing. So with the amines, you get the N-amide again. This group leaves, which forms the carboxylic acid. And remember, the acid anhydrides are used in preference to the acid chloride because of the hydrogen chloride gas that's given off. So this section here, which I've not gotten in great depth with, you can have a look at the videos from last week if you want to have a look at those in a lot more depth than I've just gone there. It's just looking at the amines with the acid chlorides and the acid anhydrides in terms of their nucleophilic addition elimination reactions. And then just a recap there and some questions for you to have a go at.